Welcome to the second video on the Chemisode series for Unit 2 VCE Chemistry. This one's on the solubility of substances, and we're looking at how and why some substances dissolve and how and why some substances do not dissolve. As I said before in the first video, we have an Edmodo group, which you can see the group code at the top of the screen now. If you join that group code, what you can actually do is download the notes for these podcasts and these videos, and you can also see the worksheets that I hand out to my class. You can also see some quizzes, so some online quizzes about the topics that we cover here as well. So if you join the Edmodo podcast, you can interact a bit more with these videos and get some feedback and also ask some questions and get some help. So let's go have a look at this second video, which is about the solubility of substances. First of all, before we get stuck into it, here's some prior knowledge that you should have, some understanding of a few things. You should understand what ionic compound formulas are. You should be able to write down the ionic compound formula for different things. So if I give you a compound, such as magnesium chloride, you should be able to write down the formula for magnesium chloride. It's MgCl2. You should be able to do that, and that's knowledge you should have from Unit 1. You should also have knowledge of polarity, which we covered a bit in the first video, but we also covered more in Unit 1 as well. So these are the two things that you really should have a good idea about before we go into this video. The key words over this side, these are ones that, as I said in the first video, you should at the end of it be able to write these down in a sentence explaining how they relate to the solubility of substances. So you need to use these words in a sentence to explain the solubility of substances. Let's go and have a look at why things dissolve now. Let's go on to our next slide. What happens when a substance dissolves? Well, three things must happen for a substance to be able to dissolve. We first of all have to have the substance break apart. If the substance doesn't break apart, it's going to be stuck as a lump in our water. So the substance must break apart. The second thing, water must break apart, because at the moment molecules of water, they're all attracted to one another. In order for a substance to dissolve, it needs to be evenly dispersed throughout the water. So what has to happen? The water must move around and move apart to allow that substance to go in there. So the water molecules must break apart. And last of all, most importantly, the substance must be attracted to water. So these three things are the key things in the solubility of substances. The substance being able to break apart, water being able to break apart, and the reason this all happens is because the substance must be attracted to the water. For all these things to happen, the following must be true. The substance must be more attracted to water than itself. So if we don't have a substance that's attracted to water, what will happen is it will just be staying solid. It will just be staying by itself. If the substance is more attracted to water than itself, it means that the water will be able to take it and run away with it, basically. Okay, so this is the first thing must happen. The substance must be more attracted to water than to itself. The second thing, water must be more attracted to the substance than to itself. So that's another thing. Like, if we don't have water being attracted to the substance, and it's more attracted to other waters, it won't be able to go in between the waters. So we want the substance to be able to pull water away from other waters, and we also want this water to be able to pull substance away from the other compounds of that substance as well. So let's go have a look at the three different things that dissolve. So this is how they dissolve, basically breaking apart and being attracted to water. These are the next one, are the three types of compounds which dissolve in water. Three compounds that can dissolve. The first type of compound is a polar substance. Okay, you understand polarity, so you should be able to work out if a substance is polar or not. What happens with polar substances? They form dipole-dipole or hydrogen bonds with water. So take for instance this guy here. This is ethanol. We've got two carbons and a hydrogens and an OH group on the end here. This OH group, this is a polar region of the molecule. What's going to happen when this dissolves in water? This little polar region, we have a delta negative and a delta positive here, these two are going to be attracted to each other. So the negative region of our molecule, of our ethanol, is going to be attracted to the positive region of our water. And we're going to form a thing called a dipole-dipole bond, okay, between your negative oxygen and your positive hydrogen here. In the case of ethanol, it's special because it's oxygen and hydrogen, so therefore it's one of the FON molecules. Remember we talked about FON molecules last lesson as well. And these guys will actually form a special type of dipole-dipole bond called a hydrogen bond between it. Okay, so polar substances, they form dipole-dipole or hydrogen bonds with water. Notice that this substance, the ethanol, doesn't break apart itself. What just happens, it gets dispersed within the water itself. So you form a dipole-dipole bond between water and the substance itself. The second type are some ionic compounds also dissolve. Not all ionic compounds dissolve, just some of them. What happens when ionic compounds dissolve is they actually break apart. They completely break apart and they form ion dipole bonds with water. Take for instance this guy. Let's pretend this is sodium chloride. Na positive, Cl negative. All these green guys here, these are your chlorines, these are your negative atoms. So chlorine is a green one, and these blue looking ones here, they are your positive. So they're your sodium ions. When this gets into water, what happens is they break apart completely, and you're left with this Na positive here, the blue guy, and the chlorine negative, or the chloride ion. Notice the way that the waters arrange themselves around the different ions. With your positive blue one here, what happens is you get the oxygens lining up with your positive blue one, because oxygen, as you know, has that delta negative part of your water molecule. So that around the sodium, you're going to have all these oxygens facing inwards, and you've got an ion dipole bond forming between the sodium ion and the pole of water, the negative pole. In your chlorines, notice the arrangement of the waters around the chlorine. You've got these hydrogen guys, they're attached to or attaching to the chlorine, the chloride. This is a negative ion, and the reason we have the hydrogens jumping in and attracting to the negative one is because we have a positive and a negative, they get attracted to each other. So this is your ion dipole bond with chlorine. The last type of substance is a special one, and these are guys that are the polar substances that can ionize, where you have a really, really strong polar bond, a massive difference in electronegativity. Basically, what happens with these type of polar substances is that they ionize, that the polar bond that you have is actually so strong it actually breaks apart. This always, well, mostly always happens with acids. The polar substances that ionize are generally acids. And what happens is they break apart and they form ion dipole bonds with your water. For instance, this guy here, let's just call this hydrochloric acid, where we have a chlorine as your green guy and your white one's a hydrogen. What happens is because this bond is so polar, there's such a difference in electronegativity between your chlorine and your hydrogen, it actually snaps off and you get a chlorine here, and if I had the other part of this picture, you'd have the hydrogen up here. And again, it looks very similar to the way that the ionic compounds work. But the difference is these are polar substances that ionize. And as I said, they're mostly acids. So if you have something like that's an acid, it will dissolve in water in the way that a polar substances that ionize will. The next slide gives you a bit more information as to how we can show this dissolving in a chemical equation. So how can we actually show these three types of dissolving in chemical equations? I'm going to use the same examples I've used here, so ethanol, sodium chloride, and hydrochloric acid to show the difference in equations between these three substances. And here they are. Polar substances, when these guys dissolve, as I said before, they don't break apart. These guys don't break apart, they just become aqueous, they just become dispersed within the water themselves. So what happens is we might start off with a ethanol over here, which is a liquid. Like pure ethanol is a liquid at room temperature. When we put this in water, it just becomes an aqueous solution. This bracket with the AQ in it, this means aqueous. So we have liquid ethanol dissolving in water becoming aqueous. This is showing how it's dissolving, just where we have the starting thing as ethanol, adding to water, it becomes an aqueous solution. So we write aqueous next to the ethanol here. With ionic substances, remember we talked about ionic substances and they dissolve in water? With the ionic substances, remember how we said that they would dissolve in water? They break apart. When ionic substances go into water, they completely break apart. They get pulled away and they go into their separate ions. I actually don't have sodium chloride. I've got magnesium chloride here as an example. So when magnesium chloride dissolves, what happens, water goes in there and breaks apart, pulls the magnesium off and rips the chlorine out, and they become into their separate ions. So we show it as magnesium chloride as being a solid, starting off with that. So starting off, magnesium chloride as a solid. When it dissolves, it goes into magnesium 2+, that ion, and then it has 2 chlorine ions. Because what's happening is this is breaking apart into all the ions that it has. And we have 1 magnesium ion and 2 chlorine ions, or chloride ions, I should say. So that's ionic compounds. When ionic compounds dissolve, they break apart into their separate ions. And as I said, we start off with a solid. These guys go aqueous. I should have a bracket at the end of this one, and aqueous here as well. The last one is your polar substances that ionize. Now, as I said, these are mainly acids. Excuse me. Mainly acids are your polar substances that ionize. Acids always have a hydrogen, and what happens is they just break apart with that hydrogen. So we have hydrochloric acid, HCl. When it dissolves, it forms this H+ ion, and it also forms this chloride ion. So it just breaks apart and forms these 2 ions here. Another way of writing acids is a special way, is if we actually react it with water itself. If we react it with water, it becomes H3O positive and negative. It basically just means that this hydrogen here jumps onto this water here. It's just another way of writing it. You don't have to write it like this. You can write it like this way, so dissociating here, or you can have it so it's reacting with water and forming this hydronium ion here. We'll go more on this a bit later on when we talk about acids and bases. But for now, it's just polar substances that ionize are acids, and they break apart and the hydrogens sit on their little lonesome. Now, the word I'm kind of used before is dissociate. What dissociate means is when it breaks apart into its separate ions. So this ionic substance and these polar substances that ionize, they are dissociating. So they're breaking apart into their ions. That's what dissociate means. That's one of your key words. So you want to say when ionic substances dissolve, they dissociate and break apart into their separate ions. Let's have a look at some solubility rules in terms of ionic compounds. I think that's what's next, or some little interesting facts about different types of these things. Because as we know, not all ionic compounds dissolve, and not all polar substances will dissolve. So this is some more detail in polarity and ionic compounds. More detail in polarity. Well, with polar molecules, some substances aren't all polar. Some things have polar and non-polar ends. So if you have a substance that has an OH, so for instance an alcohol, if you have a really long chain of carbons and just one little OH at the end, it's going to have a very large non-polar end, which is a long chain of carbons, and you're going to have a polar end, which is the last little OH bit there. What happens is the solubility depends on the size of each area. So if you have a large non-polar end and only a slight polar end, what's going to happen is it's probably not going to dissolve because you need polarity for it to dissolve. So some substances have polar and non-polar ends. You should be able to identify substances that have polar and non-polar ends, and also look at them and perhaps identify where these polar ends are and where these non-polar ends are as well. So that's one thing about polarity. Solubility depends on the size of the polar end and size of the non-polar end. If you've got ionic compounds, we know that not all ionic compounds will dissolve. We talked about that a little bit last semester where we looked at the properties of ionic compounds. We saw that some things did dissolve and some things did not. In general, ionic compounds will not dissolve if the force holding them together is stronger than the force holding it or attracting the ion to water. So if you have a really strong force holding the ionic compound together, it's not going to be able to be broken apart by water. We have some solubility rules. So in general, all your first group metals, so your potassium, your sodium, and your lithium, these guys are all generally soluble. If you have any compound which has these in it, it will generally be soluble or very soluble. If you have nitrate, ammonium, and this ethanoate ion, these guys are generally soluble as well. So all these guys, I want you to try and remember, if an ionic compound contains any of these type of bonds, and it contains they're not bonds, if it contains any of these ions, these guys will be soluble, or generally will be highly soluble. I can't say that they're going to definitely be soluble, but they'll have a greater ability to dissolve. There's a full set of solubility rules for ionic compounds in page 199 of your textbook. I think it's 199 from memory. Yep. So have a look at the solubility rules for ionic compounds on page 199. But in general, if you have these ions in your compound, they will be soluble, or very soluble, highly soluble. Not completely soluble, but very highly soluble. So that's some more ideas about how you can tell if something's going to dissolve or not. Lastly, we've got some examples here, so you might need to write some of these down. So I want you to try and identify which of the following substances are ionic and which ones are covalent. We want to state whether or not they'll dissolve and give a brief explanation as to why they'll dissolve. And lastly, write an equation to show how each of these will dissolve if they do in water. So what I'm going to do is I'm going to get you to pause this podcast, to pause this video now, and then have a go at your own ideas of understanding if these will dissolve or these will not dissolve in water. So pause the podcast now and just write down what you think. Which ones are ionic? Which ones are covalent? Which ones will dissolve? And a brief explanation of why they will dissolve or why they will not dissolve. So pause it now and let's have a look at that. Okay, you're back. I should have said it before actually. Glucose here, glucose is this guy here. This is glucose, this molecule here, the little hexagonal one. Dichloromethane is this one here, and propane is this one here. So hopefully we have an understanding of glucose, dichloromethane, and propane here. Let's have a look at the first question. Identify each of the substances as ionic or covalent. I've got them all written down here. So here they are. The first one, ethanol. This is a polar substance. This one's an ionic substance. This one's an ionic substance. This guy's an acid, which is a polar substance, for instance. This is polar, this is polar. This guy is non-polar. This is ionic, and this is ionic. So hopefully you've understood how to identify each of these as polar, ionic, or polar, covalent, or ionic. The next thing is why they will or will not dissolve. Basically, this one, so the number 1, 2, 3, 4, 5, and 6 will all be able to dissolve. The reason these first 6 will dissolve is different in each case. The first one is a polar substance. That is why it will dissolve. So ethanol is a polar substance, so it will dissolve. Ammonium chloride here is an ionic substance with ammonium. This is an ion that is very highly soluble. So you'll say that this one will dissolve because it's ionic and it contains the ammonium ion. The next one is an ionic compound as well. This will dissolve because it has the nitrate ion. This one here, sulfuric acid, H2SO4, this will dissolve because it is an acid. It is a polar substance that will ionize. It's an acid. These two here, glucose, You've got lots of OHs here. The OHs tend to say that it's going to be polar. Okay, wherever you have an OH in an organic compound is a polar region, so it's going to be a polar substance, so it will dissolve. And this guy, dichloromethane, is a polar substance as well. So you can see it's asymmetrical, it's not a symmetrical molecule, so you'll have more of a negative region where the chlorines here are, and more of a positive region where these where the hydrogens are over here. So it will probably dissolve as well because it's a polar substance. So our last three things here are the things that are not soluble. So we've got one covalent compound that's not soluble and two ionic compounds that aren't soluble. The first one here is our covalent, which is our propane, so C3H8. This is a non-polar substance because it's symmetrical. So if you draw out the valence structure like I have here, you can see that it's a non-polar substance. That means it won't dissolve in water. Only polar substances will be able to dissolve in water because they have that dipole, the little positive, the little negative. Whereas this guy here, being non-polar, will not dissolve. The two ionic compounds here are insoluble in water, mainly because they don't contain those soluble ions that I talked about in the last slide. So silver chloride, because it's got a silver ion, which doesn't, and no other ion that's soluble, it will be insoluble, and calcium carbonate here will be insoluble as well, mainly because it hasn't got the soluble ions. The best way to deal with this is to look at your solubility table though, and to see if these are going to be soluble or insoluble. Because they don't have the soluble ions, your best bet is to look at page 199 of your textbook and then look at seeing if they will be soluble there. The next step is to show the equation to show how they dissolve. So first of all, we've got a polar substance. That is a really simple way of doing it. It's just simply a liquid on one side, or a solid, or a gas, and it becomes aqueous. It doesn't break apart because covalent compounds, when they dissolve, they don't break apart. The ionic compound, however, ammonium chloride, it will break apart into the positive and negative ions. You can see here. Again, ionic, it will break apart into positive and negative ions. The acid is a covalent compound that ionizes, and that will break apart into the hydrogen ions and the separate anion that you have here as well. So sulfuric acid will break apart into two hydrogen ions and one sulfate when it dissolves in water. This next one is a polar substance again. The next one's a polar substance, so you can see how we got just one compound on this side, and we just change the state from solid here to aqueous, and this one's gas to aqueous as well, because it starts off as a gas. You would normally be given what the starting state will be. And as you know, the last three here all will not dissolve. First one due to being non-polar, and the second two being ionic compounds that don't dissolve. Lastly, let's look at a summary of what we've covered so far in this video. Here's a summary. This is what you should be able to do. Basically, you want to identify substances as being either ionic or covalent. So ionic compounds, they always have a metal and a non-metal, whereas covalent compounds are only non-metals in there as well. So identify substances as ionic and covalent. Then you need to be able to identify if the substance can or cannot dissolve. So you need to look at the substance. If it's ionic, check your solubility rules to see if it will dissolve. If it's covalent, check to see if it's polar and see if it will dissolve or not. And you need to explain why and how that substance dissolves. So that's in terms of saying if it's ionic, it's going to break apart. If it's covalent and it's polar, it will form those dipole-dipole bonds with water. And lastly, you should be able to write chemical equations to show how the substances dissolve. So how that substance dissolves, just like I did in the examples just in the slide beforehand. That's what you should be able to do. Now, what are you going to do now? We have to, here's your textbook reference. This textbook reference is chapter 10.4. So in your textbook, this is all explained in chapter 10.4. There's a few questions in your textbook which you can do, which is questions 6 to 9 in chapter 10. Sorry, 6 to 11 in chapter 10. Join the Edmodo group and you can do the Edmodo quiz on dissolving as well. So there's a couple of, I think there's about 5 short answer questions in the Edmodo quiz on dissolving that you can test your knowledge to see how you go with. That is dissolving, how and why substances do dissolve or do not dissolve. Next up, we're going to look at solubility curves, and I'll get putting together that slideshow in a second. Take it easy and happy studying.